of
ఇష్టం
statement.
ప్రాణం
Instead of
నన్ను పోస్తే
statement.
కొవ్వు ఉండదన్నయ్య.
So I will use some operation.
టాలీవుడ్ ను దున్నేయడానికి పుట్టిన బాగా హీరోనన్నయ్య.
Operation. So like read, write.
మాట్లాడితే పుత్తూరు పంపేస్తా.
ఏం చేస్తాం అక్కడ వెళ్ళి మళ్ళీ ఒక అమ్ముతామేంది
బాబు
నా బ్రేక్ఫాస్ట్ క్యారవాన్ గిఫ్ట్
The operation
ఇల్లు
should
మారు
be
యాటిట్యూడ్ మారు.
The operation should be performed.
ఇప్పుడు అర్థం కాదు,
And
రేపు సూపర్ స్టార్ అయితే నన్ను చూసే గుర్తారు ఓట్లు.
we have to execute it.
అవునా ఆకాష్ ఎక్కడ?
Continue
ఆకాశ?
with the same.
తను మన
Continue
స్టాఫ్
with the
కాదమ్మా,
same.
సాంబు అంకల్ దగ్గర పనిచేస్తుంటాడు.
వాట్?
Continue with the
తను మన
same.
దగ్గర వర్క్ చేయడా?
Okay.
మీరెందుకు
Only
సీఎం కావడం లేదో నాకు
I
ఇప్పుడు
equals to
అర్థమైంది.
equals to 5, I would like to
మీరు
perform
క్రీమ్
some
ని వదిలేసి
operation.
స్క్రాప్ ని పక్కన పెట్టుకున్నారు.
Then continue.
ఏందమ్మా అంత మాట అనేసినావు?
లేకపోతే ఏంటి నాన్న?
Java, C test,
మన కింద
Java
పనిచేసే
and
వాళ్ళు
Java
ఎప్పుడైనా
test. There is
మనకంటే షార్ప్ గా ఉండాలి.
అలాంటి బ్యాచ్ మన కాడ 100 మంది ఉండాలమ్మా.
There is no
కౌరవుల మంద కూడా
abnormal
వందే నాన్న.
termination, all the operations
మనకు
are
కావాల్సింది
executed. Even
గన్స్ తో
though when
వెనకాల
we
నిలబడే వాళ్ళు
perform
కాదు,
equals
గట్స్ తో
to
ముందు
5
నిలబడే వాళ్ళు.
and divide it
ఆ తర్వాత
by
మీ ఇష్టం.
1. So let us assume I will come with the 0.
అవునయ్యా, ఇప్పుడు నా దందా బందా బాగుంది. దానికి కారణం నేను కాదు, మా ఆకాష్. ఇప్పుడు వాడు నా హ్యాండ్ కాదు, బ్రాండ్.
హలో,
ఏంపా?
ఎవరప్పా?
నేనప్పా, హోమ్ మినిస్టర్ నాగప్ప.
సార్ గుడ్ మార్నింగ్.
యాడుండవు?
సార్ ని అసెంబ్లీ తీసుకెళ్తున్నాను.
ఓ అట్నా? అయితే నేను ఆనకు చేస్తాలే.
పర్లేదు, సార్ ఫోన్ లో ఉన్నారు, చెప్పండి.
ఏం లేదప్పా, నా కాడ పని చేస్తావా?
ఏంటి సార్ పొద్దున్న జోకులు వేస్తున్నారు?
జోక్ కాదప్పా, సీరియస్ గానే చెప్తుండా.
సార్
నువ్వు నా కాడకు వస్తావా అంటుండా.
అంటే మా సార్ ఇక్కడ నాకు నెలకి 2 లక్షలు ఇస్తున్నారు.
నేను దానికి డబ్బులు ఇస్తా.
ఎప్పుడు జాయిన్ అవ్వమంటారు చెప్పండి సార్.
ఇప్పుడు వచ్చిన
ఆన్ ది వే సార్.
Overcome the problem of abnormal termination. So as a developer, all the operations,
Why,
even
sir?
the
ఏంటి?
exception,
ఏమైంది?
ఎక్సైటింగ్ ఆఫర్ ఒకటి వచ్చింది,
all
అందుకే
the
excited.
operations,
నన్ను ఇలా నడి రోడ్లో వదిలేసావేంట్రా? నాకు డ్రైవింగ్ కూడా రాదు.
ఆటో
to execute.
ఆటో నాకు మీకు కాదు.
If there is an exception, so we need to avoid that abnormal termination, to avoid the abnormal termination, to avoid the failure state.
నడి రోడ్లో
We
వదిలేసి
need to
వెళ్తాడా?
handle the
ప్రమోషన్ వచ్చిందంట
exception.
వాడికి.
We need to
ప్రమోషన్ వస్తే
handle
పని
the
ఇచ్చిన ఈ మధ్య
exception.
పనిలేదా వాడికి?
So what is
నా
exception?
ఒప్పుకోలేనాడ్రా?
Exceptions are the failure
వాడికి అసలు
statement.
నీతి న్యాయం ధర్మం లాంటి పదాలు తెలియవట్రా?
అలాంటివి మీరు మాట్లాడితే కామెడీగా ఉంటుందన్నా.
abnormal termination. We need to
లేకపోతే
avoid this
ఏంటన్నా
abnormal
వద్దు వద్దని చెప్తున్నా, నెత్తి పగల కొట్టడం తీసుకొచ్చి నెత్తి మీద కూర్చోబెట్టుకున్నారు. పైగా నేను చూస్తుంటే నన్ను నేను అతను చూసుకున్నట్టుందిరా అని పొగడతలో, అందుకే అడ్డంగా పెట్టాడు.
చెప్తానురా. What is it?
We use exception handling. So in order to use the exception handling, so we have to use 3 blocks. Try, catch, finally. Try, catch, and finally. So we have to use these blocks. To handle the exception. So we are going to use these blocks to handle the exception. So this process is called as exception handling. So what you can say, what is exception? So if there is an exception, all the operations are not executed. So in order to avoid that, so we are going to handle the exception. So the process of avoiding the abnormal termination is called as exception handling. In order to handle the exception, we are going to use the 3 block, try block, catch block, and finally block. Try, catch, and finally block. So what we are going to do is we are going to use the try. So inside the try, so we have placed exception statement. And after that, so we use a catch block. So e dot print stock trace. Okay, so simple. So now we have handled the exception with the try and catch. Simply, so Java C test.java and Java space test. So now observe, so though there is an exception, even though there is an exception, all the operations are executed successfully. All the operations are executed successfully. But without handling the exception, only few operations got executed. So this is how we need to handle the exception. This is how we need to handle the exception. So in order to handle the exception, the statement must and should write inside the try block. The statement must and should write inside the try block. Okay, the statement must and should write inside the try block. So we have to write like this. So try must contain catch. The try must contain catch, and so we have to close the catch. We have to close the catch. We have to close the catch. Okay, so this is how handling the exception. This is how we need to handle the exception. Handle the exception. Handling the exception. Handling the exception with try and catch. With try and catch. Okay. Handling the exception with try and catch. Then what is the use of try block and what is the use of catch block? We are going to discuss here. Okay. The try block is used to identify the exception. Try block is used to identify the exception. Identify the exception. Identify the exception. Okay. Identify the exception. So once it is identified, the identified exception is hand over to catch block. Is hand over to catch block. Is hand over to catch block. So what catch block will? So catch block will store the exception object. Will store the exception, or you can say handle the or catch the exception. Catch the exception. Catch the exception. Handle the exception, store the exception, or catch the exception. Okay, so try block is used to identify the exception. Catch block is used to store the exception or catch the exception. So what is the use of finally? The finally is execute. So finally is execute. Finally is execute. So release. So release locks. Release locks or close the files. Close the files or connections. Close the files or connections. What are the connection? DB, database connection. Database connection. Okay. All right. So observe here. So release the logs, or close the files, or close the database connections. Close the database connection. Close the database connections. So try block is used to identify the exception. Catch block is used to store the exception or catch the exception. And a finally block is used to release the logs or close the files or close the database connection. So this is how try, catch, finally blocks will work. Okay, so simple. So instead of this, I will close this system.out.print. Simple. Okay. For better understanding. So what I would like to do is int 100 I is equal to 100 by 0. There is an exception, so we have to place inside the try. Okay, so just observe here. After placing into the try must contain the catch. Try must contain the catch. So catch exception here. And within the try, so I will just write system.out.println. So try, and within the catch also I will write system.out.println catch. Println catch. And I will write some finally also. Finally block. System.out.println finally. So let us assume with exception. If 0, 0 exception. If 0 exception. If 1, no exception. If 0 exception, if 1, no exception. Okay, so if it is a 0, what are the statements are going to be executed? Okay, so just observe the catch and finally got executed, but the try block is not executed. The try block is not executed. The catch block and finally block executed if there is an exception. If there is an exception, suppose let us assume if it is 1, no exception. If it is 1, no exception. Then what are the statement? The try and finally, but not catch. So what is the difference? When there is an exception, then only catch block will get executed. The catch block always get executed when there is an exception. But you can observe the finally executed with exception, finally is executed without exception. The meaning is finally irrespective of the exception. Okay, with exception and without exception. With exception and without exception. Okay, so but the catch block only with the exception, the finally with or without exception, the finally with or without exceptions get executed. So what is the use of try block? Try block is used to identify the exception. Catch block is used to store the exception, catch the exception, and finally will release the logs, will release the files and close the database connection. By using these 3 blocks, we are going to handle the exception. So we are going to handle the exception. Why we need to handle the exception? Why? Because if it is no exception handling, there will be a abnormal termination. There will be all the operations are not get executed. So as a developer, must ensure we have to handle. For that, we use try, catch, and final. Okay, when the catch block is going to get executed if and only if when there is an exception. When the finally block will get executed with exception or without exception. So irrespective of the exception, it always get executed. Then what are the exception meaning is there is hierarchy. Exception hierarchy in Java. Exception hierarchy in Java. So you can observe. So this is the hierarchy. You can observe this is the hierarchy. So already I discussed that object is the superclass 2. Object is the superclass to all the Java classes. Object is the superclass to all the Java classes. Okay, so there is another class called as throwable. The throwable is a subclass to object class. Object class. So very guarantee question. What are exception handling? Can you describe exception hierarchy? So you need to draw this diagram. In the examination. Okay, so the superclass is called as object, and to the object throwable is the superclass. And all the exception classes, there are so many exception classes: runtime exception, arithmetic exception, null pointer exception, class cast exception, IO exception, SQL exception. You can observe all the names are ended with an exception. that comes under exception classes. That comes under exception classes. Some other classes are available. Some other classes are available like stack overflow, out of memory, and virtual machine error, and assertion error, IO error, AT error, and some other classes end with error. End with error. So all the problems, the abnormal terminations are categorized into two types. One is exception and another one is error. One is exception and another one is error. So basically we should handle the exception but not the error. We should handle the exception but not the error. Why? Because exception classes are deal with the coding and error deal with the hardware. So coding part comes under the exception. The hardware problem comes under the error. The most of the error comes with the hardware problem. So that we are not responsible for the hardware. So as a developer, as a programmer, we should handle the exception only. So but abnormal termination may be happen with the exception as well as error. But we should handle only the exception. So all the classes are categorized into two types. One is exception classes, another one is error classes. So to all the error classes, error is the superclass. To all the exception, whatever the exception, that may be a runtime, that may be a arithmetic, that may be a class cast, whatever is the exception, that comes under exception class. So all the exception classes, exception is the superclass. Okay. So simply hierarchy. So first, what is the superclass? The superclass is called as object. To the object, one subclass is available. The subclass is nothing but throwable. And to the throwable, there are two classes again. To the throwable, there are two classes. One is exception class, and then another one is error classes. So another one is error classes. Under the exception, you can write any exception like runtime exception, and runtime exception is a superclass to arithmetic exception. Arithmetic exception, like that you can write exception, arithmetic exception, and you can also write IO exception. The diagram can be anything, right? And IO error, and also you can write AWT error, and you can also write out of memory. Out of memory error, out of memory error, out of memory error. So whatever it is. So object is the superclass and the throwable is the subclass. The throwable is nothing but superclass to exception and error. So runtime, and runtime is arithmetic, as well as exception is the exception, and error IO, and as well as out of memory, and as well as IO error. So I draw this diagram, better understanding. So some exception classes are there, some error classes are there. To all the error classes, error is the superclass. Error is the superclass. To all the exception, so exception is the superclass. Exception is the superclass. To the exception and exception and error classes, throwable is the superclass. To all the Java classes, so object is the superclass. So this is what you need to understand. So for superclass is object, to the exception and to the error, throwable is the superclass, and to all the exception is the superclass. To all the error is the superclass. You need to draw this diagram. Okay. By seeing this diagram, so by seeing this hierarchy, So you can conclude all the names started with a capital. All the names are started with capital. That means these are classes. That means these are classes. That means these are classes. Object is the class, throwable is the class, exception is the class, runtime exception is the class, arithmetic exception is a class, null pointer exception is a class, index out of bounds exception is as a class. So what is the conclusion is? What is the conclusion is? Exceptions are nothing but classes. Exceptions are nothing but classes. Or to the classes we can create the object. To the classes we can create the object. So in that point of view, exceptions are nothing but object. Exceptions are nothing but predefined classes. Exceptions are nothing but predefined classes. You can observe that. You can observe that. Under the exception, there is a separate class called as a runtime exception, and there is some classes are called as IO exception, SQL exception, and DWT exception. So what is the meaning is? What is the meaning is? Some classes comes under runtime exception. Some classes comes under runtime exception. Some classes are not in under the runtime exception. Okay, so runtime exception is important. Runtime exception are important. So runtime exception. Runtime exception. Some classes are available inside the runtime, like arithmetic, like arithmetic exception, like arithmetic exception, and class cast exception, class cast exception, and array index out of bounds exception. Array index out of bounds exception. Some classes or not comes under runtime exception, IO exception, SQL exception, SQL exception, SQL exception, and AWT exception, AWT exception. Some exceptions comes under runtime, some exception comes under runtime, some exception not comes under runtime. So generally, so the exceptions which are under the runtime exception are called as unchecked exception, or called as unchecked exceptions. The exceptions which are not under the runtime exception are called as checked exception, or called as checked exception, or called as checked exception. There are two terminologies: unchecked exception and checked exception. Unchecked exceptions are the exceptions which are comes under runtime exception, which are comes under runtime exception, and checked exceptions which are not comes under runtime exception. Okay, you can see the hierarchy here. You can see the hierarchy here. So under the runtime exception, there is arithmetic, there is null pointer, there is class cast, there is index out of bounds, there is array index and string index. So all these exceptions are directly subclass to runtime exception. Directly subclass to runtime exception. So these arithmetic, null pointer, class cast, index outbound, and array index and string index exceptions are called as unchecked exception. Unchecked exception. Why these are unchecked exception? So if it is divided by zero, you will get an exception. You will get an exception. So what type of an exception? You can print that. You can print that. So after that, so e dot print stock trace. E dot print stock trace. E dot print stock trace. So simple. Java C tester Java and Java tester. So this is the arithmetic exception. This is the arithmetic exception. So when we get this exception, when you compile, it will not give an exception. So when you try to execute it, then only it will give an exception. So exceptions are occurred at the time of execution itself. There is no compile time exception. There is no compile time exception. But some exceptions are checked by the compiler. But some exceptions are checked by the compiler. The compiler will give the warning message. Compiler will give the warning error. So those type of exception are called as checked exception. So when you try to compile, there is no error message and there is no prompt and there is no statement saying that you are going to get an exception, so please handle it. Why? Because this is arithmetic exception. Why? Because this is arithmetic exception. So int I is equal to 100 by 0. Definitely there is an exception. But when I try to compile, there is no message and there is no prevention. But when you try to execute it, so directly you got the exception. Directly you will get the exception. But if it is some other statement like class dot for name, if it is some other statement like class dot for name, so com dot mysql dot jdvc dot driver. So simply I written this statement. When I try to compile it, that's it. When I try to compile it, so when I at the time of compilation itself, it is giving the error message. There should be a class not found exception. You are going to get a class not found exception. You must be caught or declined to be thrown. You have to handle it. You are going to get this exception at the time of compilation. At the time of compilation itself, we get the error message. But when I try to execute, so then we get the exception. So simple. So some exception at the time of compilation, some exceptions are checked and some exceptions are not checked. Some exceptions are checked and some exceptions are not checked. So at the compile time, some exceptions are checked by the compiler. So those type of exceptions are called as checked exception. Some exceptions are not checked by the compiler. So those type of exceptions are called as unchecked exception. Informally, so professionally, we can say unchecked exceptions comes under runtime exception. Checked exception not comes under runtime exception. The subclasses of runtime exception are unchecked. So there is no runtime exception. There is no subclass to the runtime exception. Those exceptions are checked exception. So you can write two definitions. So what are unchecked and what are checked? So unchecked exceptions are subclasses to runtime. So checked exceptions are not subclasses to runtime. So checked exceptions are checked by the compiler. Unchecked exceptions are not checked by the compiler. But finally, exception occurred at the time of execution itself. But some exceptions are checked. So whether you are going to get an exception or not, so those exceptions are called as checked exception. So you can see the diagram. So runtime and its subclasses and error and its subclasses are unchecked exception. Only runtime exception and subclasses runtime are the unchecked exception. So remaining all are checked exception only. The meaning is arithmetic, null pointer, class cast, index out of bounds are unchecked. So IO, SQL, AWT, interrupted, file not found, and end of file exception, interrupt IO, file not found. So all these exceptions are checked exception. So this is about checked and unchecked. And so one more thing is, so by using this statement, you are going to get an exception. By using this statement, you are going to get this statement. But exception is the superclass. So that is the reason why. So directly you can place a subclass into superclass. Suppose arithmetic exception AE. Arithmetic exception AE. So I can write like this also. write this also. So next, arithmetic exception is subclass to runtime exception. Is a subclass to runtime exception. So that I can write runtime also. I can write runtime also. This is our exception and this is our catch. Next. Runtime exception is a subclass to exception. Time exception is a subclass to exception. So now I'll continue with E and E catch. And exception is a subclass to throwable. Exception is a subclass to throwable. I'll continue with a variable called as T. So this is T catch. Okay. So there are multiple catch blocks. One is arithmetic, one is runtime, one is exception, one is throwable. So to the single try block, we have defined multiple catch blocks. So the catch blocks from subclass 2. Arithmetic exception is a subclass to runtime exception. Runtime exception is a subclass to exception. Exception is a subclass to throwable, and throwable is a subclass to object. Actually speak, we have to write object also, but respective of the exception, object not comes under the exception. So object is the root object. So we can't write object as a catch inside the catch block. Okay, right. So up to throwable you can write. So arithmetic exception is a subclass to runtime exception. Runtime exception is a subclass to exception, and exception is a subclass to throwable. Okay. So if there is an exception, which catch block is going to get executed? So that is the question. So why? Because we have multiple catch blocks. So AE catch block got executed. If I delete this, so which catch block got executed? So just observe the R catch. The R catch is nothing but runtime exception. If runtime exception is also deleted, so it will execute exception catch. Suppose if I delete the exception catch also, it will execute obviously throwable. So what is the object? First arithmetic, next runtime, next exception, next throwable. So we can define multiple catch block to the single try block. Multiple catch blocks to the single try block. But the order must be subclass to superclass. Okay, so try to observe. The order is what? Subclass to superclass, but not superclass to subclass. The meaning is first should be a subclass called as arithmetic. If not arithmetic, it should runtime. If not runtime, it should write with exception. If not exception, it should write with throwable. But not like this. After runtime, you should not write arithmetic. Okay, why? Because arithmetic exception is a subclass to runtime. You can write subclass then superclass, but you should not write superclass then subclass. Okay, so when you try to write this like, so it will give an error message. The exception already been caught. So what is the question? Can we write multiple catch block to the single try? Obviously we can, but we have to follow the order. The order must be from subclass to superclass we should write, but not superclass to subclass. So this is what about try, catch, exception handling, checked exception and unchecked exception. So there is one more thing. So actually speak, to handle the exception, we use three blocks. First one is try, second one is catch, and third one is finally. Okay, when there is exception, only catch block will get executed. When there is no exception and when there is an exception, so finally block will get executed always. So with exception or without exception. So let us assume there is an exception. So it will not give an error message. It will not give an error message. Why? Because it is unchecked exception which are not checked by the compiler and which comes under runtime. But when you execute this, we will get the definition. We will get the exception definitely. Okay, right. What we need to do here, we need to handle the exception by using try, catch, and finally. But instead of that, if there is, just follow the statement. If there is something, so com.kite. So something statement. So forget about this something. Simply, I'll try to compile this class. So when I try to compile this class, it will give the error message, not exception. It will give the error message. The error message saying that you are going to get an option exception called class not found exception. You have to be caught. You must and should be caught. Must be caught ante. So that exception must be catch by the try, catch, and finally. Or there is another option, or you have to declare to be thrown. The meaning is you should handle the exception by using the blocks called as a try and catch. Why? Because you are going to get an exception here. So that is the reason why. So it is not allowing to compile the class. So simply, so what we need to do is, so instead of try and catch, you can also use a keyword called as throws. What is the throws and what is the exception? The exception name is class not found exception. You can declare like this. The exception name is class not found exception. So directly you can write. Then you can compile. And then you can execute. So when the time of execution, we got the exception. At the time of compilation, there is no exception. There is error message. So this type of exceptions are called as checked exception. When there is a checked exception, it is not possible to compile. So without try, catch, and finally, but you can also use the keyword called as throw to handle the exception called as class not found exception. So where is the class not found exception? The class not found exception available here. The class not found exception is a subclass to exception, obviously. Why? Because every exception is a subclass to exception. So directly you can write exception also. You can compile the class successfully. Instead of exception, you can also write throwable. That is also fine. Why? Because all the exception classes comes under throwable. So instead of try and catch, to handle the exception, we can use the throws. Then what about the throw? So the throws is used to handle the exception. So without declaring try and catch. So throws keyword is used to handle the exception. So without declaring try and catch. There is a keyword called as a throw. The throw keyword used to create new exception object. So if I want to create a new exception object, then you should use the keyword called as exception object. How you can how you can create a new exception object. Suppose let us assume I would like to develop a class called as name valid exception. Name not valid exception. So name not valid exception, or instead of name is not valid, is not valid exception. You have to write this class public class age not valid exception. It must be subclass to a superclass called as exception. It must be a superclass called as, it must be a superclass called as exception. So inside this we have to create one constructor. We have to create one constructor, the constructor with age, the constructor with age. Let us assume constructor with age, constructor with age, constructor with age. So simply I will use this dot within this private edge, and from this constructor, you have to call the super. From this constructor you have to call the super. From this constructor you have to call the super. The super is nothing but calling exception constructor, exception class constructor, exception class constructor, exception class constructor. Other method, public void verify age, int age, verify age int age. Okay, in this method I will verify like this: if age not greater than, if it is or less than 18. Okay, if not, if less than 18, less than 18. So now I can create new exception object with the help of throw keyword. So new age not valid exception is not valid exception. So this is how you can create a new exception object. You can create a new exception object with throw keyword. With the throw keyword, the throw keyword is used to create new exception object. The throw keyword is used to create new exception object, but throws keyword is used to handle the exception without declaring try and catch. So this is the difference between throws and throw. Throws and throw. So these are predefined. These are predefined, already defined by the Java people. Predefined exception. Age not valid. Age not valid exception is the user defined exception. This is the user defined exception. This is the user defined exception. So do you know how to define an exception? So obviously the user defined exception, so must and should be the subclasses to a superclass called as exception, and from the subclass constructor you should call, from the subclass constructor you should call superclass constructor. You should call superclass constructor, and when there is a requirement you can create a new exception object. You can create a new exception object. So basically exceptions are the object, or exceptions are the classes, or exceptions are the failure statement. And so we can say, so all the exceptions should be handled to avoid the abnormal termination. To avoid the abnormal termination. For that we have the try, catch, and finally. For that we have try and catch and finally. Try block is used to identify the exception. Catch block is used to catch the exception or store the exception. And finally block always executed without and with exception to release the logs, to close the files, to close the database connection. And there are hierarchy. There is an hierarchy. Object is the superclass, and throwable is the subclass to object class. And to all the exception, exception is the superclass. To all the error, error is the superclass. Okay, so all the exceptions categorized into two types. One is unchecked and another one is checked. So unchecked exceptions are not checked by the compiler, which are subclasses to runtime. So checked exceptions are checked by the compiler, which are not subclasses to runtime exception. And there is a throws keyword to handle the exception without declaring try and catch. Throw keyword is used to create a new exception object. And so we can say there are free-defined exceptions are available and there is user-defined exception. Definitely you will get a question how to define our own exception. So in order to create our own exception, you have to create our own exception, we have to create an exception object which extend the superclass called as exception, and from the subclass constructor we should call the superclass constructor, and after that you can use the throw keyword. So these are the point you need to remember while attending your examination. So from this exception, so most of the questions you will get. Okay, so next.
సార్ ఒకసారి దిస్ రిపీట్ చేయాలి సార్ ప్లీజ్.
ఎక్సెప్షన్స్ రిపీట్ చేయాలా?
దిస్ కీవర్డ్ సార్,
దిస్ కీవర్డ్.
ఎస్ సార్.
ఓకే, right, simple. Let us assume there is a class I would like to develop, public class student, public class student. I will save this student.java. Okay, and I would like to use one variable here without the int student id, int student id, and int student id, and one more method, or do one thing, private int student id. Simply to understand, student id, this is the variable. Private string student name, private double student average. Okay, so student id, student name, and student average. So id is integer, name is string, and average is double. So as we know that the public things we can access from anywhere, but private things we cannot access outside the class. Only within the class we can access. Suppose let us assume, so these are non-static variable. These are non-static variable available in the student class. Okay, simply I can create the student class object. I can create the student class object. I will try to access student.student id. Student.student id is equal to 101. I'll try to store it. So I will create the student object. I'll try to access the student id which is available in the student class. I will try to insert, but student id is a private, so only within the class, within the student we can access, but we'll try to access it in test. Okay, so when you try to compile the class, so it will give an error message, student id as a private access in a student. So directly you cannot assign the value from outside the class to the private methods, to the private variable. Then how can you assign to this id? So simply we'll take one public and we'll take one method. So student id, set student id. So the variable name is int and student id and student id. So with this method, with this method we can assign, with this method we can assign the data. So what is the method name? Set student id. So directly I will call, directly I will call from the test. So instead of accessing directly private variable, so I will use student dot set student id, set student id. So I will supply 101, I will supply 101. So the 101 value will go to this location. The 101 value go to this location called as student. So just observe. I have student here. I have student here and I have the test here. I have the test here. I have the test here. Okay. From the test, I am calling the student ID. The 101 directly will go to the variable called as a student. There are two variables. One is this student ID and another one is this student ID. So this is called as instance or global variable. This is called as instance or global, and this is called as local variable. Okay, the supplied value is going to be stored inside the local but not in global. Okay, actually we have to assign the data to the global, right? But with the help of set student, with the help of set student, with the help of set student, with the help of when I try to execute, so public int get student ID, get student ID. So I will return here. I will return here student ID. So when I call this method, I will get the student ID. So what is the method name? Get student ID. So simple. So system dot out dot println, system dot out dot println. So std dot get student ID, get student ID. Observe 101 is applied to the set student ID, and after that we are calling get student ID. The set student ID for storing get student id for getting. Okay, but in the set student id we have written only the statement, right? Why? Because global variable name, global variable name and local variable name are same. Local variable name are same. Okay, simply after setting the value, after setting the value, so we should get 101. Actually we should get 101, but what the value we got? 0. Why? Because why? Because what this statement happen is, the local variable data, this local variable data is assigned to same local variable data. When the local variable and global variables are names are as threads. There is concept called as threads. Okay. So generally, let us assume there are some operation or there are some task. So task 1 and task 2. So like that, there are so many tasks we have to perform. Task N. To perform these tasks, we are going to define process. We are going to define the process. The process is nothing but the procedure to perform the task or operation. The procedure to perform the, and the program. Process is also nothing but a program, so that can be perform the particular, can be execute the task. So we can define multiple process. We can define multiple process to execute the task. We can define multiple process to execute the task one by one, one by one. So let us assume Let us assume task 1 contains 1000 lines of code. To the task 1 contain 1000 lines of code. 1000 lines of code, we define, let us assume we define two processes. extending the extending the thread class. Okay, implementing runnable interface, extending the thread class. So what are these two? There are two possible to define the threads in Java. There are two possibilities define the threads in Java. Okay. Okay, so implementing runnable interface, extending thread class, implementing runnable interface and extending the thread class. What is runnable interface and what is the thread class? So we need to see the API. There is a default package called as lang package. So what package contains? Already I told you the interface assigned, class assigned, exception, class assigned, exception. So now there is an interface called as runnable interface. There is an interface called as runnable interface. Runnable interface. So runnable interface available in java.lang package. Java.lang package. So when it comes to only single method is available, only single method is available. The method name is run method. The method name is run method. So runnable interface available in java.lang package and it contains only run method. Coming to thread. Thread is a class. Thread is a class available inside the same java.lang package. Java.lang package, but it contains multiple methods. But it contains simple. I will write one class here, public. First you have to define the class, right? So create a class with runnable or thread class. So I will create one class here, thread 1, which implements runnable. I am using the runnable. Let us assume I am using the runnable. The class name is thread 1. The class name is thread1.java. Thread1.java. So what is the first step? First step is create a class with runnable or thread class. Next. What is the second step? Override run method. Override means same method name and same parameter within the subclass and superclass. So run method system.out.println. System.out.println. Okay, run method. Next. What is the third step? Call the start method from the thread class. So for that, public, I will create a main method, public static void main string args, and open the main method and simply thread 1. So instead of thread t1, dot start t2 dot start. So these are multiple threads. You can create this dot get. I think there is a method. Get name. Okay, get name. This dot get name. So this is nothing but object. So this is nothing but object. Which object? Thread class object. Which object? Thread class object. Which object? Thread class object. Simple. Java C thread1.java. Oh, cannot find symbol. The symbol name is get a name. Just a minute. Okay. Current thread. Okay, Java space thread 1. Okay, so run method executed, which is a thread 1, run method execute, which is thread 2, and run method execute, which is thread 0. So there are three threads defined. Okay, there are three threads 0, 1, and 2. There is so thread called as 1, and thread called as 2, and thread called as 0. So meaning is we define three thread classes here. Okay, I will define one more class here. I will define one more class, thread class here. Okay, so let us assume this is 3 t3. So t3 dot start, 3t dot start. Okay, so simple. Java C thread 1 and Java thread 1. So now observe. So 0 is there, 1 is there, 2 is there, 3 is there. So totally 4 threads are executed the run method. 4 threads are executed the run method. So this is how we'll create the threads. This is how we'll create the threads. So for that we need to follow the procedure. We need to follow the procedure. The procedure is only two ways are there: by implementing runnable interface, by extending the thread class. So we have to create a class with runnable or thread class. I have declared the created the thread class with runnable. So that second step we need to follow, override the run method. So I have override the run method here. So within the run method, just I have written run method and along with the current thread. So next, and after that, so follow the third step, call the start method from the thread class. So you need to call the method called a start method. So but start method directly call the run method. So in order to call the start method, we have defined 4 threads here. So this is what you have to define the thread. So start method internally calls the run method. So then what is the difference between threads and normal? So instead of start, you can also write run method, but you would also write run method. So no issue. So but you can observe. So in the previous example, the 0 thread is executed the run method, but when you don't write any start method, when you don't call any start method, directly there is no thread. There is a thread called as main thread. So it is not recommended to call. Run method directly. So instead of run method, you should use you should call the start method. Then it will call by the thread. Thread 0, thread 1, thread 2, and thread 3. So mandatory you have to call the start method but not run method. The procedure is common. So if I want to develop the same program with the help of class called as thread, so again we need to develop the class. So now I will like to develop thread 2, which extends the properties of thread class, called as thread class. So here you no need to use the runnable. You can use the thread class here. Okay, so after that same thing, you have to override the run method. Within the run method also you can write the same statement. So system.out.println. The println is nothing but run method, and which contains thread dot current thread. And after that you can declare a main method, public static void main, string args. And within the main method you can define multiple threads. So here thread, so t1 is equal to new thread 2. Okay, after that thread 2 t2 is equal to new thread 2, and t3 is equal to new thread 2. So you can define any number of threads like this: t1 dot start, t2 dot start, and t3 dot start, t3 dot start. So you can define any number of threads and call any number of types. You can call any number of types here. So simple Java C space thread 2 now. Java C space thread 2 dot Java, thread 2 dot Java, and Java space thread 2, Java space thread 2, Java space thread 2. So now you can observe thread 0, thread 1, and thread 2 are executed. Thread 0, thread 1, and thread 2 are executed. So you can use anything by using the thread class or by using the runnable. What are the changes? Only when you create an object is different. If it is a runnable, we'll create the thread class object. So what is the difference? So I will paste the difference. Okay, simple. This is runnable, and this is thread class, and this is thread class, and this is thread class. So for better understanding, I will do one thing. Okay. Okay. Next, thread 1. Okay, so the procedure is common. Like the run method and call the start method is common. Run method and call the start method is common. But what is the difference? So if you create the thread by using runnable, you have to create the object like this. Okay. So this is the difference. That's it. So remaining program is same. So if you create the thread and if you use the runnable, or if you use the thread, what is the difference? The difference is only when you create the thread. Okay. Right. So this is the difference. The difference is clear. So only object creation to the class is different. So remaining all are same. So you have to create the class. What is the class name here? So here you created thread 1. Here you created the thread 1. So simple. Here you created the thread 1. So here you created the thread 2. But at the time of object creation, if it is a runnable, so you have to give the object to the thread class. But if it is a thread 2, which extend the properties of thread class, you no need to use the thread class itself. Directly subclass object you can create. So this is the main difference. So remaining all the programs are same. So within the thread 1, so this is how we need to create the object. But run method and call the start method are common. So in the same, run method and start method is common, but only the difference is the way you create the object. Is different. So this is how we'll create the threads in Java. This is how we'll create the threads in Java. So when you observe, so there is a 5 and there is a 5 and there is a 5. So these are nothing but thread priorities. These are nothing but thread priorities. Generally there are three priorities in thread. Generally there are three priorities in thread. So one is maximum priority. Is maximum priority. One is maximum priority, one is minimum priority, and one is normal priority. So threads are three priorities. Threads will have the three priorities: the maximum, minimum, and normal. So what is the minimum? Minimum is 1 and normal is 5 and maximum is 10. So what is the normal priority? 5. What is the minimum priority? 1. And what is the maximum priority? 10. So based on this priorities only, so the thread scheduler will execute the thread. Thread scheduler will execute. The thread scheduler is there. This thread scheduler will execute the thread. Will execute the threads based on their priorities. Based on their priorities. What are the priorities? So priorities may be a normal. The priorities may be a minimum. So minimum priority and normal priority and maximum priority. So what is the minimum? The minimum is, what is the minimum? The minimum is 1. The minimum is 1 and the minimum is 1. The normal means 5 and maximum means 10. So these are the priorities. You can observe the priority. Thread 0 is priority is 5 and thread 1 priority is 5 and thread 2 priority is 5. So main is the parent thread and thread 0 is a child thread. So you can like a parent and child here. The parent thread is a main and the child thread is thread 0. And the priorities or normal priority 5 and 5 and 5. Okay. Next. There is a life cycle methods. There are life cycle methods in thread. There is a life cycle statements. There is a life cycle threads in Java. So life cycle thread means what? The simple. There are some states. The states are nothing but new state, runnable state, running state, dead state, and waiting state. We'll discuss. Simple. If I use like this, thread dot sleep. So 1000 milliseconds. Let us assume like that. 1000 milliseconds. Java C thread 2.java. So uninterrupted exception must be caught or declined it to be throws. So I can use throws keyword. So interrupted exception, but I can use the superclass called as exception. Still there is no directly I will use with the class. Okay. CLS Java C thread 2.java. But still there is no exception. So I will continue with try and catch. Catch exception e dot print stock stress. Okay, right. So simple. Okay, Java C thread 2 dot Java and Java space thread 2. Java space thread 2. Okay, so first I'll continue with some 500, 1000, 5000. Okay, thread 2 dot Java, Java threads. Okay, so meanwhile I will use like this. Okay, try and catch the same sleep method after start. Here 500, so here 500 milliseconds. We'll discuss. Okay, this is not run, this is a main method. This is main method, thread 2, thread 1. So now you can observe one is run method, one is a main method, and run method and run method. Okay, so instead of 500 you can also use 1000. Okay, so main method is executed first, then run method. So next run method is executed and then main method. Okay, so it is not completely static, so it may be a dynamic changes. Okay, so sometimes it will execute main statement and sometimes it will execute run statement. So this will make independent mechanism. So generally the programs, so one depends on another. So without the main and complete of the main, then it will enter into run method. So once enter in run method, the main method will not get executed. But when you observe, one time run method, one time main method, one time main method, and one time run method. So this is how threads will share the common area. Thread will share the common area. So threads will enter into same common area. And sleep method is used to so make threads wait into waiting state. Threads wait into waiting state. So observe here. There is a new state. There is a new state. There is a new state. There is a new state, and there is a runnable state. There is a running state, and there is a waiting state, and there is a dead state. When you create a new thread, means in a program you are creating multiple threads, right? You are creating multiple threads. So this state is called as new state. This state is called as new state. So when you call a start method, so this is called as new state, and this is called as runnable state. This is called as runnable state. And when it enter into the run method, this is running stage. And when you call the sleep method or wait method, this is waiting state. This is waiting state. Okay. And after execution, all the statements are completed. So now this is a dead state. This is a dead state. So now observe. So when you create a new object, so it is a new state. When you call a start method, it is a runnable state. When the run method is executing, so it is a running state. While running the execution, so when you call sleep or wait method, it is a waiting state. And when you, after completion of all the statement, it is a dead state. So this is the life cycle state or life cycle methods or life cycle threads or life cycles of threads in Java. So new state, runnable state, running state, waiting state, and dead state. Okay, all the state. So what is the difference between sleep and wait is actually wait method is from a class called as object. Actually wait method is from a class called as object. Wait is a method. Wait is a method available inside java.lang.object. Okay, so you can observe. So cause the current thread to wait until another thread invokes. The meaning is, so current thread will enter into the waiting state. Current thread will enter into the waiting state, and it will be invoked, and it will be invoked by another thread. It will be it will be invoked by another thread by using notify or notify all methods. Notify or notify all methods. There is a method called as notify, and there is a method called as notify all. So by using notify, it wake up single thread. It wakes up single thread from the waiting state. By using notify all, it wakes up all the threads from the waiting state. So the difference between so wait and the difference between wait and sleep is, so to the sleep method we are going to supply the time in a millisecond. To the sleep method we are going to supply the time in a millisecond. So after time expires, after the time expires, automatically it will wake up or it will invoke from the waiting state. But when you call a wait method, so until unless other method calls notify or notify all, it will not invoke from the waiting state. It will not invoke from the waiting state. So that is the reason why. So this will cause current thread to wait until and unless another thread will call the notify and notify all. So what is the difference between a notify and notify all? So by using notify, we can make or we can invoke a single thread into running state again from the waiting state. By using notify all, so we can invoke all the threads from waiting state to another running or runnable state. So whatever it is. So these are the life cycle of threads. These are the life cycle of threads. So you can see the method names. See here: start, run, notify, notify all, sleep, and wait method, and run method. So these are the life cycles of. So you can draw any of this diagram. You can write any of this diagram. So all the diagrams are right. All the diagrams are right. So the new state, runnable state, running state, dead state, and waiting or sleeping or notify, notify all, and wait, sleep, as well as start method and run method. Start method and run method. So this is about threads. So how many ways? There are two ways: implementing runnable and extending the thread class. Extending the thread class. So procedure to define the threads in Java. So first we have to create the class with runnable or with thread class. So we have to override a method and we need to call the start method. Then what is the difference when you create with the runnable and when you create with thread? So if you take the runnable, you have to create the thread class with our own class, with the thread class and our own class. But when you create a thread class directly, you can create the object to the our own class itself. No need to use the thread class. That's it. And there will be a thread scheduler based on the priorities. The threads are executed, and the priorities are minimum, normal, and maximum. So we can set the priorities also. We can set the priorities. We can set the priorities, and we can set the names. We can set the names. We can get the priorities. We can get the names also. Okay, we can set the priorities, we can get the priorities, we can set the name, we can get the name. And after that there is a deadlock. There is a deadlock concept. What is a deadlock? Deadlock is a concept. Deadlock is a concept. If two or more threads enter into the waiting state, two or more threads enter into the waiting state, and waiting for each other, is called as deadlock. Okay, deadlock is important. The deadlock is important. Okay. So just observe, there is class A and there is class B. There is class A and there is class B. So for using class A and class B, we are going to define thread 1 and thread 2. Thread 1 and thread 2. Okay. So class A contain method A as well as class B contain method B. Okay. So simply observe there are two methods and two times we are calling start. Two times we are calling start. Okay. Simply. So Java C thread demo or deadlock demo, I think. Okay. Deadlock demo.java and Java space deadlock demo. So now observe here, thread 2 is executed, locked B. Thread 1 is executed, locked A. So the B is locked and A is locked. So thread 2 is trying to locate A again, and thread 1 is trying to lock B, unlock. The meaning is, so A, it is unlocked to B. So the true threads are waiting into waiting state, and so self-locked and waiting for each other to invoke. So still you can observe the cursor. Still it is waiting. So this is called as deadlock. So when I forcefully stop, it got executed, it got terminated. So deadlock. So you can see the diagram. Deadlock in Java. So you can observe here. So deadlock. So there are two threads. So thread 1 holds the one object and thread 2 hold the object. So thread 2 wait for one object, so which is held by the thread 1. So thread 1 try to access object 2, which is held by the thread 2. Okay. So this situation is called as deadlock. So simply you can copy this code also. So same. So file, I will save as deadlock. So deadlock. So deadlock.java. Okay, simply. So Java C deadlock.java and Java space deadlock. Okay. Deadlock 1, deadlock 2, deadlock. Okay. So still it is waiting. To execute. So not working. Okay. So deadlock in a sense. So if two threads waiting or hold the same resources and waiting for each other is called as deadlock. Okay. So you can observe this diagram. Okay. So this is fine. Thread 1 is holding object 1. Thread 2 is holding object 2. So thread 1 wants to object 2, which is held by the thread 2, and thread 2 wants object 1, which is held by the thread 1. So this is exactly called as deadlock situation. And there is a concept called as synchronization. The synchronization in a sense nothing but okay. So multiple like so you can observe synchronized method. Thread 1 locks the object. Why? Because at a time simultaneously. So no multiple threads enter into the synchronized method. Synchronized block. Why? Because if multiple threads enter into same synchronized method, same area, so the output may be a inconsistency. The output may be a inconsistency. That meaning is, so the output may be different. The output may be different. So for example, the calculation, the total calculation must and should be like so 10,000 or 20,000. The total calculation must and should be equal to the 10,000 and 20,000 for particular operation. So if we define multiple threads, and multiple threads enter into the common area, so that the output may be not consistent, that not may be equal to 10,000 or 20,000. So it may be not equal to 20,000. It may be a different output. So some point of time. So that is the reason why we should avoid that inconsistent output and inconsistent result. So by restricting multiple threads enter into the same resource area, so until unless so another thread will complete the operation. So that type of operation is called as synchronization. So you can see the diagram. So thread to wait on the same instance until T1 comes out from the monitor. So you can observe that T1 is entered into this thread synchronized method. So thread 1 is locked the object, so that from the same object, thread 2 or another threads will not enter into the same object. So for avoiding the inconsistency result. So this is about synchronization. And lastly, there is a final keyword, finalize. There is a finally, and finalize. There is a final. Final is a keyword. That is applicable for variables. And methods and classes. So classes cannot extended by subclasses. Final classes cannot extended by the subclasses. Okay. Methods cannot override by subclasses. Variable data cannot modify. We cannot modify. Okay, final is a keyword that is applicable for variables, method, and classes. Variable data cannot modify, methods cannot override, and classes cannot extended. And finally, so which is used in exception handling. So it will execute. So already I told you which is used in exception handling. So finally block with exception or without exception. Always get execute. And this is used to release the locks. So now you got the idea about locks. What are locks? Thread locks, or close the files, or close the database connection, close the DB connections. So finally block is used in exception handling. With or without exception always get executed. And so these are used to release the locks. Or close the database connection, and finalize. So finalize is a method. called by GC. So GC means garbage collector. GC means garbage collector. Garbage collector. So which is a part of JVM. Which is a part of JVM to clean the data. To clean the unwanted data. To clean unused data. To clean the unused object from memory. Object from memory. So final is a keyword that is applicable for variable, methods, classes, and finally is a block that is used in exception handling. So with or without exception, so it will get executed and release the logs and close the files and close the DB connection. Finalize is a method called by garbage collector. So it is a part of JVM to clean the unused object